All right, moving into chapter 14, and hopefully you've done some practice problems from chapter 13 and you're pretty much good to go for those. So chapter 14, we get into our more specific probability rules. Let's recap one of the things we learned from the last chapter. When two events A and B are disjoint, we can use the addition rule for disjoint events. Probability of A or B is equal to simply the probability of A plus the probability of B. Pretty much when it's or, you add. However, what are we going to do when the events are not just disjoint? So we need to take our addition rule from the last chapter and fix it. All right, so you don't use a different, well, you kind of use a different formula. We basically are just going to make the general addition rule that we can use for any events, disjoint or not. If the events are not disjoint, then this formula will double count the probability of both A and B occurring. And you can look at the picture here. This probability of A is this entire circle. And the probability of B, this one here, is that entire circle. So when we add those together, this intersection is actually being added in both groups. So you're counting them twice. So there's a simple fix for that. We just need to subtract that overlap out. So that we add it twice, we subtract one out, and that way we're not double counting that section. So your general rules, probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So this is the formula that we're going to use more than we're going to ever use that formula. But just remember, if the events are disjoint and they can't happen together, then this is just 0. And that's why it's not here, because it would just be 0. So you don't have to subtract anything out. This formula is on your formula sheet. It's the first formula on the top right side of your formula sheet. So you want to make sure you know where that is. Also, just be aware, I have our formula sheets where formulas on one side and formulas on the other. On the AP exam, these are actually going to be on the next page. It's actually another page of formulas. All right, for example, a survey of college students found that 56% live on campus. So we'll call that campus is 0.56. 62% participate in a campus meal program, so we'll call it meal, 0.42. And then we're being told campus and meal, that says do both, so that's both of them, is 0.42. I have a number wrong here. This is 0.62, sorry. This is 0.42. This is campus and meal when they say do both. So the question is, what's the probability a randomly selected person either lives or eats on campus? Or is the important word there. So we just learned this formula. We want to know what's the probability that they live on campus or they have a meal plan, eat on campus. And looking at my formula, I know it's the probability of living on campus plus the probability of having a meal minus the probability of living on campus and having a meal. Because these people are counted in both of these numbers. So it's just a simple application of the formula. So I'll add those and subtract on my calculator. And I'm getting a wrong answer because I forgot the point on this one, 0.62, and I'm getting 0.76. So that's the probability or the proportion of students that do one or the other. Now, we're going to learn now how to make Venn diagrams for this scenario. This is going to be really, really important. It's going to really help you with these types of questions. So the first thing I'm going to do is draw a rectangle for my sample space. And these two events overlap, so I'm going to draw two circles, and I tend to make ovals more than circles. It kind of helps me draw these better, that overlap. And the one thing you need to remember, and this is what students mess up the most, is if this is your lives on campus circle, the entire circle is 56%. The entire circle is 56%. And if this is your meal plan circle, your entire circle is 62% or 0.62. This section is the both. That's 0.42. Now I can write the 0.56 out here if I want to, but then you need to remember that that is the group of people, that's the whole circle, that includes them. So actually what I'm going to do is out here, I'm going to take this portion of the circle out of the 0.56. I'm going to take 0.56 and I'm going to subtract the 0.42 and I'm going to get 0.14. And I'm going to write that here. And what that is, that's the people who live on campus but don't have a dorm. So together these two add up to the 0.56, which is everyone who lives on campus. Whether they don't live in the dorm or they do live in the dorm, this circle represents everyone who lives on campus. Let's do the same deal with the meal plan people. The whole circle is 0.62, but we've already covered 0.42 with this portion of the circle. So that leaves me with 0.2 out here. Now, if I add up those three numbers right there, 0.14, 0.42, and 0.2, you get this number here. That's all the people who either live on campus or have a meal plan, so that you get this same number. If you add those up, you get this same number. So what about the people who don't do either? Okay, that's the people outside the circles. Remember, that's a complement. 0.7. These are the people in here that do one or the other. So the people out here don't do either. If these add up to 0.76, then the leftover is 0.24, and that's the amount of people who don't do either. And this is what a Venn diagram would look like. And if you make the Venn diagram, it actually makes the answers to these next few questions really easy just to see. You don't have to do any formulas because you've already done all the math. So what's the probability that a randomly selected student lives off campus and does not have a meal plan? Lives off campus and does not have a meal plan. So that's that 0.24 that we just calculated. I don't need to use a formula for that. I can just use my diagram. That's why the make a picture mantra is really so important. What's the probability that a randomly selected student lives in a resident hall, so they're in this circle, but does not have the meal plan? Well, we already calculated that as well. That's 0.14. So just kind of look out for the scenarios of when to do which. When you are told the probability of A, the probability of B, and then the probability of both, oftentimes a Venn diagram is very helpful. You can also make contingency tables. You could do who lives on campus, who does not, and then who has a meal plan and who does not. So these tables are going to look like our tables did in chapter 2, where we could fill in all of these pieces and parts. They have to add up to 1, which would be everybody, or 100%. And you remember your total live on campus is 0.56. That goes out in the margin. That's regardless of whether you have a meal plan or not. But lives on campus and has a meal plan is 0.42. And the total amount of people who have a meal plan is 0.62. And then from there, these are the three numbers told to me in the problem. And from there, you could start subtracting and calculating these other pieces and parts. And you start building all of these other numbers is what ends up happening. So this is 0.14. This is 0.2. You could calculate this guy. This is 0.38. And then figure that this guy here is you could do this one too, 0.44 and 0.24. And everything should add up. And now you have all of the possible different probabilities that you could potentially ask for. The Venn diagram is a little more visual than this. I could go from this to the Venn, from the Venn to this much easier, as opposed to from this to the Venn.